So dear students, in this video we are going to do Biot savart law. It is a subtopic from the chapter 4 itself, Biot savart law. So Biot savart law is basically defined as the magnetic field due to a current element is equals to the magnitude of the current flowing through the current element, that is I, the length of the current element dl, and inversely proportional to the square of the distance. So what it mean by this statement is, suppose you have a current element, suppose you have a wire where there is a I current flowing in the wire, and suppose you take a very small dl element. Dl is the length of this very small element of the current conducting wire. Now due to this particular dl element, there will be some magnetic field at this point P, which is at a distance of r, which is at an angle of theta with the dl element. So due to this dl element, there will be some magnetic field at this particular distance of r, which is actually inside the plane of the paper. The magnetic field will be inside this plane of the paper. Why? We will do this. We will see this afterwards. So now, according to definition, the magnetic field, let dB is the magnetic field at this point P. So this dB will be directly proportional to ideal, okay. In other words, I can write this as ideal cross R. This particular dB will be directly proportional. Okay, we'll come to this particular definition afterwards. So firstly, I am writing it in another form. So dB is directly proportional to ideal cross R, and dB will be inversely proportional to the square of the here I'm writing cube of the distance, but I have written here square of the distance, so we are coming it to later. So this dB together will be proportional to ideal cross R divided by R cube. Now since it is a cross product, so the direction of the dB will be given by your right hand rule. So when you go from dl to r, you have to curl your finger this way. dl to r, this is dl, this is r, so you have to curl your finger this way. So this direction is the direction of dB, inward. Thumb will give you the direction of the dB. So dB is basically inward at this point P. When you change this proportionality constant, proportional sign by constant, so then it will be like dB is equals to mu 0 by 4 pi I. Now dl cross r is nothing but it is dl r sine theta divided by r cube. So proportionality sign is replaced by this proportionality constant, and dl cross r is dlr sine theta. So 1 r and cube get cancelled. So your dB will be equals to mu 0 by 4 pi I dl sine theta by r square. So this is the value of the magnetic field at this point P due to a current element dl, where mu 0 4 pi is a proportionality constant, where mu 0 is the permittivity of the free space. Not permittivity, actually it is permeability of the free space. Mu 0 is the permeability of the free space, and the value of the mu 0 by 4 pi is 10 to the power minus 7 Tesla, something like it will come out to be something Tesla per meter. Okay, it may come out to be Tesla per meter, so you have to check this unit. Is it Tesla per meter or something else? So you have got your magnetic field due to a current element. Now let us this particular Biot-Savart law where the magnetic field due to a current element will be mu 0 by 4 pi I dl sine theta by r square is much similar to your Coulomb's law. This is from magnetostatics and this is from electrostatics, where Coulomb's law, the electric field due to any charge will be q by 4 pi epsilon naught r square. So these two are more similar relations. For example, first similarity is both are inverse square law. That means both fields, this is a magnetic field and this is your electric field.